Okay. To start with, currently we are working with about 65 plus customers or biobanks across 16 countries. Most of them, majority of them is in US, and some of the big ones like Washington University, University of Miami, Emory University. In Pittsburgh, we have Hillman Cancer Center. And a large client base is also in Australia. University of New South Wales is one of our oldest customers. And we have Victorian Cancer Biobank, which is a large consortium of the collection sites, and they use OpenSpecimen since a long time now. And some of them in Europe, like Netherlands Heart Institute, University of Basel, University of Leicester, and the large hospital at Singapore, which is Singapore General Hospital. As you see, most of them are universities, research centers, and a lot of centers use OpenSpecimen at enterprise level and for multi-site studies. So we'll see some of the examples during the actual demo of the product. So to start with overview about us, so we have been working on biospecimen data and this domain since a very long time now, and we have been working with many biobanks across the globe. And our primary focus is on OpenSpecimen. So it is development of the product, implementation at different centers, helping them install, training, data migration. So everything about OpenSpecimen is what our focus is. It supports different types of collections, may it be prospective collections or general biobanking collections or longitudinal collections like clinical trial-based studies. And it, as I mentioned earlier, it also supports multi-site studies. So it has a very powerful role management and privileges setup, which will help you control who can access which data and who can see or perform certain operations within OpenSpecimen. So you can conduct multi-site studies and collect data across multiple sites in OpenSpecimen. You can also collect non-human specimens. Some of our clients like UC Davis, they do collect non-human specimens. And within the same OpenSpecimen instance, you can do both human samples as well as non-human samples. So you can build different studies, and the way the user interface looks and the data fields that needs to be captured can be configured at individual study basis. So now let's dive into the features of OpenSpecimen, why, to highlight as to why most of these leading research centers use OpenSpecimen. One of the main highlights is OpenSpecimen is highly configurable. So as we have been working with multiple biobanks in different domains and different research areas, we have realized that the workflows are different. So one size does not fit all. So what we have tried to do is provide OpenSpecimen as a platform and make it configurable in terms of what data they can capture, how they want to capture. All these are highly configurable. The next highlight is about user roles and privileges. You can control at a very granular level as to what every user can do and what user can see in the system. It can be controlled. You can collect high quality data. So OpenSpecimen, when you install, it comes with a base model to capture basic demographics of the patient, many annotations about the specimen, like starting from collection, processing, storage, distribution. And in addition to this base model, if you want to create any new annotations based on the research you're doing, like any clinical data or pathology data, you'll be able to create your own new custom fields as well. So one of the favorite features of OpenSpecimens among our end users is the reporting tool. One is it is very easy to use. Any end user can create their own reports. They don't have to depend on the IT. And the other is they can create any type of powerful reports, adding filters, doing calculated searches. So there are multiple features, some of which we'll try to show in the demo. And then next highlight is scalability. So it can perform with high, throughput biobank. There is, our customers who have more than 2 million samples, and there's no complaint about performance issues. And we try to have new releases every 4 months. As we get feedback from different customers, we keep developing the new features, fixing bugs, and releasing new versions. So it's rapidly improving. It's 100% audit trail. Everything that is done in the application, so starting from user login, add, edit, delete, everything is audited. You can create reports based on that. Finally, it's very easy to do integration. So it is 100% REST API based. So you can integrate with applications or instruments. So some of the examples which we have already done for customers are clinical trials, clinical database systems like REDCap, OpenSpecimen, getting pathology reports from COPAT, and instruments like automated freezers, barcode readers, and recently we are also working to integrate with liquid handling systems. So this way, integrations is also useful and done that way. And so these are some of the highlights of the product. So let's go into the actual demo to see just a quick overview of what is available in the software. First of all, we have this public demo site. The URL is very easy, demo.openspecimen.org. Anybody who wants to try the software, they can sign up for an account and you'll get the login details. When you log into the system, you'll see a home page like this. Right now, I've logged in as a super admin, so I see all options in the system. Based on what role you have, the user interface is also driven based on that. So let me show you what are the different roles. So when you install OpenSpecimen, it comes with default roles. For example, administrator, coordinator, researcher, technician, tissue banker. So these are some of the default roles. But you can create your custom roles as well. Since this is demo type, you see some, bench scientist, storage administrator. These are some custom roles someone has created. So let's just see one of these roles to give you an idea that how you can control what permissions you can give to a particular user, like whether they can, create, update, or even they can delete, export, import data in bulk. And this resource will control what data they can access or what operation they can perform. So once you have these roles in place, you can create any number of user accounts. So once you and you can give these roles to specific users, which is applicable to them when they log in. So this is about the role. So next, let us look at the freezer management. So whenever you collect the specimen, you're going to store it in your repository. And your repository might have multiple types of freezers, may it be -80 freezers, liquid nitrogen tanks, or it might be, just a cupboard where you store archive tissues or paraffin tissues. So all those kind of storage containers can be created within OpenSpecimen. So it is flexible enough to create any type of storage repository or storage freezer. So this is an example of a -80 freezer. Again, this is just an example. You can mimic exactly how your freezer looks like. You can design the structure based on it. So this particular freezer has 4 shelves and it has some racks. And when I drill down, I can click on a rack. So it will show me all. It's as if you open the freezer, then you pull up a rack, and within that rack, you see different boxes. So there are some boxes which hold fluid samples, tissue samples. So, and this hierarchy of the freezer, the naming of the boxes or containers, how you use these positions, everything is configurable. So it's very flexible how you design these freezers. And now when I click on a particular box, I can see the samples within it. So what specimens are stored. So when I click on one of the cells, on the right side, it will show me an overview of what specimen is it, from which study was it collected, from which patient. So this way, you can get the whole, inventory overview by looking at this graphical view. There's also a view of list view. So there are two different views in containers or freezers. One is the graphical view. One is the list view. You can download this report, take a print, and you can go near your freezer if you're doing like inventory auditing, or you can do different actions from this. So that's about the freezer management. So the next one is collection protocol. So collection protocols refer to any kind of specimen collection which is grouped for a particular biobank. So it might be, if you have a general biobanking collection, you can create a collection protocol for it. If you have different longitudinal studies or clinical trial-based collections, you can create collection protocols for it. So to give you an example of the study definition, so this is just a demo study. First is you associate it to one or more sites. So site can be the collection hospital or the repository where it is stored or the laboratory where it is processed. So this will decide who has access to this particular collection protocol. Then you can assign a PI, coordinator, start date, end date. So these are the basic details of the study. You can do consent management. Suppose you don't have a different application where you are entering consents. You can also have consent statements like this and define at each study level, so that at the participant level you can register consent responses like yes, no, withdrawn. This will be helpful for you to do reporting. So give me all samples who have, some patients who have consented for processing DNA. And this consent is also helpful to validate consent when you're giving away samples to researchers. So that is the consent. The next part of the study definition is you can build an event calendar. So we talked about two different types of collection, right? One is the longitudinal based collection, where you might have different event points where you collect the samples. It might be like a baseline or screening event, blood collection, surgery, post-surgery follow-up. You can have multiple time points like this where you can preset everything that you plan to do in that study. This is helpful for your data entry because you're setting up a template, so you don't have to re-enter these information every time. So what you see here is the template for your collection. So you're saying that in the baseline, you're collecting the blood, you're processing into plasma, you're collecting another blood, processing into serum, and there is a surgery event where you plan to collect tumor and non-tumor sample, which you plan to freeze it, and so on. And again, if it's not a longitudinal based protocol, if it's an unplanned biorepository, then you don't have to define everything upfront. You can enter the details as you collect. So there are many other settings in the study definition. You can set up container auto location, label format and printing, barcode format, and so on. So this is the study definition. So now let's look into the data entry or the data collection stream. So when I go into the demo study, the first screen I see is the dashboard. So I'll see some graphs, which again, per protocol you can configure. So this is like a summary view of what specimens you have for your protocol or study. Then I can go to the view participants list. So the example I'm showing you is a participant-based study. So in some studies, you might not want to collect patient information. So you can also create specimen-centric protocols as well. And these data about participants is not mandatory. So this is the list of all the patients registered to this protocol. Now, if I open one of the participants, so this gives me an overview of the participant demographic details. Again, the screen from now on, whatever you're seeing, these are all configurable. So this is just to show you a demo of what is available by default. But if you want to add new fields, delete, remove certain default fields, that is easily done. Can be easily done. So this is the participant demographic page. And if you scroll down, you can see that you get a highlight or summary of how many visits this patient has come for, what kind of specimens have been collected, what specimens were missed, and what are the pending visits which plan to be done in the next 6 months or whenever. So all this is based on how you have set up the study template. Okay, so now if I click on one of the visits, it will show me all the specimens that are collected. So if you see here, there are also color coding to indicate different status of the specimen. So red indicates the specimen. There was a whole bed which was collected, but it was completely utilized, so that it's not available. Purple means it's a reserved sample for a particular PI. Blue means it's a sample that is already given away, so if you see it's not stored and not available. Green means it's a collected and stored specimen. And if I click on a specimen, you see there are more details about the specimen itself. So all these are specimen-related annotations which you can capture. Again, these fields are also, you can hide it or add new fields. So these are all the default fields. Just to quickly show you, there are also additional annotations you can create. These are called forms in OpenSpecimen. You can add any number of forms and add data for it. So once you have all this data, then you can do reports. So I'll show you a couple of example reports to give you an idea. So in reports, you can have two different types of reports. One is the raw database report. So if I show you this report. So this is an example of raw database report. So I can have filters like this. I can say, give me all specimens which belong to female gender patients, belonging to a specific race. So I can add filters. So what reporting allows you to do is you can add filters on any field, including any custom fields that you create, and view results like this in table format. And the columns that you see in this report are configurable. You can export these reports. You can schedule these reports to run on a nightly or monthly basis. And then you can export the data as well into CSV or Excel format. So this is an example of raw data report. And this is an example of a count-based report. So this is a summary report. So you might have used pivot table in Excel. So you can build such Excel type summary reports as well. This again can be saved. They can be shared with other users, and they can be scheduled to run at any regular intervals. So these are some of, and there are many other complex features in OpenSpecimen. You can do calculated searches and things like that. So that's about the reporting. And finally, we have the orders module, which allows you to track the specimens which are going away from your repository. So you get a request from researchers that they need a set of samples for their research. So you remove it from your repository and mark them as something called as distributed in OpenSpecimen. So if you see these specimens, these are all the distributed specimens. So at every specimen level, there is an audit log of what happened to the specimen, starting from collection, storage, transfer from one location to another, distributed. So every status is tracked, and you can do reporting based on this. So that was a quick demo of the features of OpenSpecimen. Starting, as you see, you can track the whole life cycle of OpenSpecimen from collection, who collected, where was it collected, when was it collected, to storage, where exactly in the freezer is it stored, which freezer, rack, box is it stored, utilization as to which researcher did it go, where was it distributed, and processing. So how many aliquots were made, how much of the parent specimen was utilized. So all this can be tracked within OpenSpecimen. Okay. So with that, I'll end my demo, and I'll pass on to Dave Mulvihill from Washington University. Till then, if anyone has questions, you can let us know in chat. Yeah, so I have made Dave as the presenter. Just give me a minute. I can't hear Dave, so.
And the beekeeper.
Yeah, Dave, can you speak up now? And
Sorry.
Yeah, it sounds like there's a lot of background.
Your name, please?
Yeah, hi, can you hear me? This is Dave.
You can indeed.
Yeah, Dave, we can hear.
All right, and you can see my screen okay?
Yes, we can see.
Okay, perfect. So thanks for inviting me to speak about our OpenSpecimen usage at Washington University. My name is Dave Mulvihill. I'm the Director of Informatics for Siteman Cancer Center, and I'm here with Lee Myrick, who is a clinical informaticist on my team. Just a disclaimer to start with, we are not being paid by Khrushchevny to talk about OpenSpecimen. We pay them. They are a vendor of ours. So we do like talking about OpenSpecimen, and we do like presenting about how it's used at our institution, because I think it's good for others to understand in the community on how we use it. And you know, if we can grow the community, it just makes the application stronger and better for us as well.
Yeah, so I'm sorry to interrupt you, Dave. I see a pop-up window of presenter view.
Gotcha. Is that better?
Yeah, now it's fine. Thank you. Thank you. Yeah.
Okay. So I'm going to talk about background and usage at WashU, and then some of the integrations, some of the neat things that we're doing with it, and then just end with a summary. And of course, we'll take questions at the end. So we consider the application of OpenSpecimen at Washington University to be enterprise-wide. I and my team work for the Cancer Center. We primarily are concerned with oncology clinical trials, but the application and its support through my team is used across multiple disease groups. And the idea is, at least at my institution, is that we'll have some investigators that kind of grew up with a little bit of funding, and they're new investigators, and they're doing things that might not be best practice. So they're putting specimen information in Excel files or Access databases, and they're putting the specimens in freezers that might not be monitored in their labs. But then as they get more funding and they understand the logistics efficiency of maintaining the data and whatnot, they reach out, and we reach out to them and say, look, we have this application that we can utilize that would be following best practices for data collection, storage, and safety and HIPAA compliance and all that. And it allows them to utilize the full functionality of the application versus a homegrown Access database, for example. So in our environment, we have some very high throughput, very large collections, all the way down to the smaller investigator labs that might only have one study with one clinical research associate that's managing just a handful of participants. I'll talk about the big ones, but just so you understand that in our institution as it is now, we run from really high throughput to smaller labs. So generally speaking, you saw the demo from Purnima about what the application looks like and its basic functionality. Why we like it is it's highly configurable. So you just saw a little bit of how the configurations work, but everything that we thought of, especially when we were migrating from our legacy system, and we were thinking about how do we do X, Y, or Z, and we would find the ability to do that right within the UI versus our legacy system where we would have to have a developer involved or maybe a database administrator to help us configure or make configuration changes. You saw a little bit about reporting. That's obviously a very strong component of any informatics system. To be able to report out for metrics tracking, for financial billing information, or just for kind of a pseudo integration if you want. You could do that. Again, there's excuse me, there's support for multiple groups. We could have very large, high throughput biobanks with multiple people, various different roles, touching different protocols, and then again all the way down to the single investigator working out of his office and storing specimens. These groups can share specimens, they can share equipment, freezers, and the like. One of the pain points, and I'll describe this a little bit as we go, was that our legacy system was on the slow side, and it was something that we were critiqued on a lot. You know, nobody wants to click a page change or enter data and then just have to wait for that page to refresh or reload. And that's where we were before. And actually one of the compliments that we got after we implemented Khrushchev's version of OpenSpecimen was, this is like night and day. This is very fast, and it was refreshing for the biobankers, you know, the techs actually doing the work, entering the data, to be able to use a modern application like that. Again, you know, we're talking about this because we like to talk about our implementation at WashU, and we consider ourselves part of the community. There's, you know, open source community forums. Khrushchev answers information or questions on the forums. We try to monitor the forums and provide feedback when appropriate as well. So I think that you know, as the community grows, it just strengthens the application. The application can grow and mature as well. And again, support from the Khrushchev team and developers on the forums, as well as you know, our deep interactions with their team has made this the use of OpenSpecimen implementation really nice. So just a little bit of a history here. So we do have a history with Khrushchev and Purnima and Shri and the team there, and hopefully this will kind of give you an idea of why that exists and why we have that the history with the team. So in 2004 through about 2010, CA Tissue was a product that was developed through NCI, National Cancer Institute program called the Cancer Biomedical Informatics Grid, or CA-BIG for short. So the goal of CA-BIG was to provide cancer centers with kind of a base suite of applications that would allow them to get on with the oncology research and not have to worry about software development. So there was, you know, products for patient registration and clinical data entry and things like this. And CA Tissue was a component of that application suite that dealt with just biospecimens. So it was biospecimen information management system. So obviously we adopted CA Tissue circa 2006, somewhere around there. Washington University was funded through the CA-BIG program to develop the CA Tissue application. We are also funded to support the application. So there were some adopters throughout the United States that were adopting these different suites of applications, and they would ask questions on the forums and we would answer those. And again, we were one of the main developers of the application. So fast forward to around 2013 to 2017, the CA-BIG program was shut down somewhere around the 2012 timeframe. So funding dried up. There was no support for the application's use. There was no support for application customization. So what happened was, what we saw institutions do is they either went to other vendors or they started forking local versions of their application to meet local requirements, which is exactly what we did. We had in-house expertise. We had CA Tissue developers that would help us customize the application and kind of move it along from this older CA Big code base that we had. The problem with that was that CA Big had, for interoperability reasons, some kind of really heavy architecture for the application integrations between their applications, which was great for integrations, but what it ended up costing was the end user would pay for that. So the easy example is clicking for a data entry page. That would go off and it would try to run a bunch of API calls to do the integrations that needed to happen on the back end while the user is waiting for that data to refresh. So that's where our pain point was. We started working with Khashoggi end of 2017, early 2018, doing some pilot testing and looking at their product. And what they did was, since OpenSpecimen CA Tissue was open source, they were able to take the application as it was and basically strip away everything that wasn't needed. At this point, it's basically a rewrite of what CA Tissue used to be. But what we noticed is, again, the customizability that's there, the reportability that comes out of the box with it, and the built-in integrations and speed. And I'll talk about those as we kind of go through some of the slides here. So just the baseline, I kind of talked about what, as far as the labs, I'll get into those a little bit later, but just some brief stats, just so you have an idea of what we're talking about here. We have over 1,000 studies in OpenSpecimen. We have over 100 sites that are active within OpenSpecimen. We have in between 180 active users per month. This is metrics that we pull, that we look at monthly to see where we're at, and it's usually between 80 and 100, just depending on what folks are doing that month. We have over 200,000 participants loaded in the system, over 2 million specimens, and around 1,200 storage containers. So a lot of things, a lot of objects in the application, and again, the speed is just phenomenal. I'll talk about our main users of the app, and this is our kind of our laboratory-based approach here. So both Lee and myself and my team work for Siteman Cancer Center, and the reason why it kind of doesn't make sense for a cancer center necessarily to be the owner and the supporter of a biospecimen informatics system, but in our case, what we call the Tissue Procurement Core, or the TPC, they are one of the largest users of the application. They have the most folks in the lab processing oncology specimens. So it made sense from that point of view that we would support their operation, we being the cancer center. So the TPC is a centralized resource to collect, store, and utilize human specimens for cancer research, but they also do non-oncology as well. So we'll talk about some numbers around the Alliance studies that they work with a little bit later. Another center, so I would consider this one probably a mid-size site for collection and processing of specimens. At WashU, it's the ADRC, Alzheimer's Disease Research Center. So they obviously process specimens related to Alzheimer's disease. What's kind of unique about this biobank is that they have different cores within the center that touch the specimens at different points. So they have a clinical core that will meet with the participant, register the participant, and collect clinical information. That participant will be passed along to the biomarkers core, where the specimen is collected and processed, and then that specimen will be sent to another core where it will be stored away for long-term analysis. So while this data is being collected and processed, the specimens are, the users are actually going into the system, and they're able to process and view the data that they need to for that either the participant or the specimen or the freezers, refrigerators, whatever they're getting into. The third example I have is our ATRC, our Kidney Translational Research Center. So they're, I would say, on probably the smaller size the lab that we have. They provide data and biospecimens for more than 3,500 study participants with kidney diseases, and they don't have a complex workflow where they're passing specimens around different cores in their center, but they have all the functionality that the high throughput TPC does. So in other words, they are intaking specimens, they're seeing participants, they're printing labels, they're going in and entering data about the aliquots and storing them away, and then further processing for DNA or molecular analysis downstream. Okay, so I'm going to talk about some of the integrations we have here. We have quite a few that I could talk about. I think in some degree these might be considered integrations, in some degree maybe not, but I'm going to talk about three of the big ones, which is REDCap, Biomes, and then some of our custom integrations. So our REDCap integration is absolutely phenomenal because out of the box you get integration with OpenSpecimen that allows the staff to minimize or even eliminate data entry, which obviously reduces errors. And you can actually pull in REDCap data, clinical data, into OpenSpecimen and report out of OpenSpecimen all the information that's related to a participant with no effort at all. So the ADRC core that I was talking about, where they enter their clinical data, this is their exact workflow. They enter participant data first in REDCap. That gets messaged over to OpenSpecimen. The participant is instantiated with an OpenSpecimen within the correct protocol, and the time points are created, and the specimen time point can be occurred in OpenSpecimen if you set the integration up appropriately. So it actually works really, really nice. So single point of entry for this registration, and it migrates over. So the bottom portion of this, these arrows where it says sync clinical data nightly, we don't actually do this, but I wanted to talk about it because if you did enter clinical data, I mean, that's what REDCap's for, to enter encounter data that's not appropriate for annotation for the biospecimen. But you could have that sync over to OpenSpecimen, again, run a report so that you're not going into multiple systems to pull out data ad hoc and then trying to put it together in an Excel and do metrics on it or whatever. We don't do that. There hasn't been a use case for that, but I did want to talk about that as being an option. So the Alliance for Clinical Trials for Oncology is kind of a cooperative group that's made of other cooperative groups. I think in around 2011 or so, these three main cooperative groups got together and said, yes, let's partner and do things together. So they manage specimens for large multi-site projects. So what Washington University does, we're one of the biorepositories for Alliance. The other one is Ohio State University. So there's several different studies that are ongoing. There's CRAs, clinical research associates, at the different sites throughout the United States and Canada that are performing collections. And they don't care about OpenSpecimen. They don't care about what you do with the specimen. They just want to collect a specimen and ship it to the centralized repository. And what this Biomes application does is just that. It allows for the processing and the shipment of that biospecimen. But before I talk about that, talk about some of the statistics for the Alliance. So they're part of the NCTN. They're funded by the NCI. So this is it's a big, huge cooperative project. They have over 3,000 collection sites across the USA and Canada. This equates to about 5,500 to 6,000 users in their system that are going into the Biomes application, creating registrations for these clinical studies, and entering information about the biospecimens, and then, virtually shipping it within the Biomes application. So there's been about over 100,000 biospecimens collected across 66 clinical trials to date. So this is what I was talking about. So the application is for registering subjects, creating those specimens, and then creating the shipment. So where this becomes really, really powerful, and what's really unique and neat about this is that this all happens automatically from Biomes to OpenSpecimen. The person who uses Biomes has no concept of OpenSpecimen, but all the data that they enter within Biomes is messaged over to OpenSpecimen and available for TPC to process the specimens when they receive the physical specimen. So the Biomes application uses the OpenSpecimen API to auto-register the trials, the subjects, and the primary specimens. And then when the CRA goes into Biomes and says, yes, I'm physically shipping this on today, FedEx is going to pick it up tomorrow, whatever the case is, that information goes over to OpenSpecimen and says, there's a shipment, it contains these specimens, here's the manifest. That way, when the specimen box comes to the lab, they open it up, they have a printout in the box that has the specimens that are in there, they compare it to OpenSpecimen, makes the receipt of those extremely easy. The tech in OpenSpecimen goes and processes those specimens, whether they're creating aliquots, derivatives, whatever they're doing with tissue, freezing it away. And then that information actually gets pulled back out of OpenSpecimen and updates Biomes. So that way the CRA that was working on that specimen knows that, well, the sample was quantity not sufficient, or it was received broken, or it was perfectly fine and it's been received and stored away. So some other integrations that we have, we're actually piloting this right now, is molecular data quality assurance type information from Qubit or TapeStation. This is kind of call it a poor man's integration, if you will, but these instruments aren't necessarily meant to have a full bidirectional electronic interface. They just aren't designed that way. What the lab is doing right now is they're taking information off of the Qubit and TapeStation via USB, and they're taking it to their desktop. They're opening up the USB, opening up the file, making some manipulations to it, and then doing a bulk upload into OpenSpecimen. And what we're piloting right now is to get those files off of these analyzers, and then allow those to be dumped into a location that OpenSpecimen is aware of, so that it can go through an automated bulk process. So that would remove the operations of the technician to go in and manually be updating the files and removing them from the analyzers. The other integration we have is with our financial system. It's called AIS for our institution, and we pull out information from OpenSpecimen through an ETL tool. And again, this isn't, you could argue that this isn't probably the preferred definition of an integration, but we do provide that information to our AIS system, so that way that users of the bigger biobanks like the TPC, they get billed for, again, services that they use and specimens that have been stored for the last 12 months and things like that. So some future direction we're looking at, right now we are working with a plugin called Project Tracker. So we're collaborating with Krishagni on this, and the concept is that that this would be able to track biospecimens and projects that have services associated with them within OpenSpecimen. So right now, this is a very highly manual process. There's a project manager in the TPC lab that would get a request, and it's usually emailed. Sometimes they have a legacy website that someone would go in and say, I need this service done. How do I go about doing this? or they would even get a phone call. That's logged on a sheet, and it would be something like, I need 4 tissues of a certain race, a certain gender, and I need those processed into curls and DNA made from them, something like that. And this piece of paper would follow those specimens through the lab, and every person that would touch that would indicate, yes, I've done that, I've done what I'm supposed to do, and it's done. That the project manager of the lab would sign off on it and say it's done, and get back to the person who initiated the project. We've basically taken that workflow and mimicked that electronically as a plugin with OpenSpecimen. It's being piloted right now within the TPC lab, and we expect this to be released in probably 3 to 4 weeks for use in the system. So this is something that that we actually had funded and made available. So we're funding the plugin, but it's going to be available. My understanding is for anybody that wants to adopt the latest version of OpenSpecimen. It's just going to be there. The hope is that we would get it to a point where it's good enough for our purposes, but we can always extend it and always have the community provide feedback to Khrushchevny, or even maybe potentially fund other components of it that might be useful. Like, for example, being able to bill from the services that are created within the service tracker or within the project tracker, something like that. So that's coming soon. A concept. This is not in development at all. It's just something that we've talked about at previous OpenSpecimen meetings with Khrushchevny about, and the idea of this specimen kiosk. And we thought it would be kind of useful and efficient for the clinical research associates that are coming to the lab, and they're actually on site here, and they're walking that specimen down and dropping it off. What we see is sometimes there's a disconnect between what they drop off and the actual paperwork that they've are dropping off with it. It might not be correct, it might not be accurate, it might be the wrong time point, and then it causes problems, obviously trying to correct that. So this would be something similar to what you see in kind of fast food places now, where it's just self-service. You go in there and there's kind of a self-help dashboard touch screen that they could go up and they could log in and then say, yes, I'm associated with this collection protocol. Yes, I have this participant. Yes, this is the visit I have. And yes, this is the specimen I'm dropping off. So it kind of does like a self check-in and walks them through that. Very, very basic, very simple workflow, not as complicated as, for example, a biobanker would be using the application. But again, that's for discussion and something that we kind of threw around. So just to summarize, we're extremely happy with OpenSpecimen as it's been implemented here, not only from the informatics point of view, but our users are excited about it. They're happy with the way that it's used. And when we talk to them about the ability to extend it and enhance it and get their feedback on things, they get excited about it because they want to see a better product. And they see that since we've adopted the Khrushchevny version, we've gone through a couple iterations, and it's something that just making their lives more efficient and better, so that they can concentrate on the research in the laboratory. But we consider it a robust and enterprise-worthy informatics platform for management of biospecimens. And its features that we like a lot are that it's open source. It has a pluggable architecture, so if you want to create plugins, you could at your own institution, or we could, solicit other community members to help, or we could just engage the vendor, Khrushchevny, to assist us. And we really like that there's a community around this. So it's, if you're siloed and you have other input on how to use the application or the best practices for that, it makes it sometimes a little bit difficult to understand that maybe there is a better way to do something, and be like that part of the community. And this is just a portion of the team at Siteman, and I think we're ready for questions.
so much, Dave, for the presentation. That was a great overview of how WashU is using OpenSpecimen at enterprise level. I'll take back this screen. I just have few things that I would like to wrap up, and we'll take questions in the chat, or we have some time for more questions. I just wanted to highlight, since most of the attendees are newcomers, if you want to know how to evaluate OpenSpecimen, so one of the things we do regularly is we conduct dedicated one-on-one online demo. So we get the client to enter a questionnaire, understand the requirements, and try to do the demo based on their workflow. So we'll be able to do that. You can contact us for that. The other thing we do is we also set up a server, like a staging server, where again we set up studies, appraisals, user accounts. We get some sample examples, use cases to you, and we create a tailored set server for you so that you can get a good feel of how the system will work in your environment. And we have references all over the globe. We are happy to get in touch, introduce you to them who have been using from a very long time, like, for example, Dave Mulvihill. So you can get feedback. You can, talk to people who are doing similar kind of research and understand how they're using OpenSpecimen. So we're happy to do that. Other than that, we have multiple resources which you can use. One is the demo site which I used for today's demo. You can sign up for an account. The other is we have all the health manuals online. So this is our Confluence wiki. It's public. You don't need a login to access. We have user manuals which you can access and try around the software. And then we have the public forums. So many end users actively use this forum to ask questions around technical questions, product related questions. We also use this forum to announce any new features, any new versions that we are developing. So as you see, there is a lot of active communication that happens here. So you are welcome to subscribe to this, and you'll be updated with anything that is happening in OpenSpecimen. And finally, you can always contact us at contact@openspecimen.org if you have any specific questions or want to schedule a demo with us. Thanks everyone for joining the webinar, and we are happy to take any questions if you have.